This is Recitation Week 3, problem number 5, not just your regular old TM. Let's take a moment and read the problem statement. Suppose we change the definition of a TM so that the transition function has the following form. Delta going from Q cross gamma to Q cross gamma cross RS, where the meaning of S is stay. That is, at each step, the tape head can move one cell to the right or stay in the same position. Suppose M is given by the 7 tuple, and it's a TM of this new kind. And suppose also that M is a decider. Show that L of M is a regular language by describing a DFA recognizing L of M. A proof of correctness is not required. Okay, so let's get some intuition for what's actually going on with this TM. Suppose we're given some input, X, like 1101. Now when we run a TM, we put the input on the tape and an infinite number of blank symbols to the right of the input. Our tape head starts on the first character with state Q0. Now what happens when we start running? Well, we're not allowed to move left, so we could possibly stay in place and transition to a new state like Q6, transition to another state perhaps and write over the original one, perhaps transition again, and let's suppose that eventually we move over to the right. Now once this happens, you notice that the head can never move left, so that position we just abandoned is dead code. Okay, now let's continue. We might make another transition and write over it, and then move to the right again. Now, it's worth noting that it's possible for the TM to halt while in the middle of the string, but for the sake of this example, I'm just going to assume that we make it to the blank portion of the tape. Transition again, perhaps do some more writing, and then transition to the blank state of the tape. Now we're going to make a couple of observations about this process. First of all, when the tape head is at some position in the string, it starts from some initial state, the first time it gets to that position I. And then there are two things that could happen. One of them is eventually the tape head will move right, like we've seen in our examples above here, and it will transition into this new state Q prime, or the TM will eventually halt while at that position and pop up in some new state Q prime, which is either the accepting or the rejecting state. But more importantly, you might have also noticed that while we were making those transitions in place, the only thing that mattered was the initial state we were in and the initial character we were reading. And why is that? Because we might have made some transition while being in place, but that transition tells us exactly what character to write on the tape and exactly what state to go into. So that transition determines the next transition, and so on. So the behavior and the state Q prime that we end up in only depend on Q and XI, the input character. We're going to make another observation. If the tape head gets to position length of X plus 1, that is, it reaches the blank portion of the tape, and it ends up in state Q, like Q12 above, it must eventually halt at some state Q prime, either the accepting or the rejecting state, which only depends on Q. Once again, it only depends on Q because in some initial state, we're reading the blank symbol, and any and all transitions that we're going to make will determine the next transitions. And we're never going to reread the input. Okay, so you might have noticed that this TM sort of feels like a DFA with some extra room for dilly-dallying. It can hang out at one spot, make a couple of transitions, but it has to move over. And how it moves over is totally deterministic based on the state that it started at. Okay, so let's try to go forward with this construction. Let's try to make a DFA where the transition function sort of just skips those few extra transitions. Before we do that, I want to mention a brief caveat with this approach. Observations of 1 or 2 are going to be true whenever we reach a state Q during the input. But what happens if we actually never reach some state Q? It's possible that there's some state Q that no matter what input we give to the Turing machine, it's never going to get to that state. And it's also possible that that state, if we start from that state, is going to loop forever. That doesn't violate M being a decider because we'll never reach that state, so M will always halt. But just to eliminate some of these annoying states, we're going to call them pointless and delete them from the Turing machine, just so we don't have to deal with any of the consequences of them. Notice that this doesn't actually change the language because we never use the state on the Turing machine no matter what input we use. Okay, now let's go ahead with the construction. Recall that M is given by some 7 tuple like this, and we want to create a DFA 5 tuple based on this 7 tuple. Now, we're going to use the exact same state set that we did before because we want to transition from one state to another state from the original TM. Now let's think about how we want to construct the transition function. So there are a couple of cases that we have to care about here. Remember, it's possible that Q is going to be the accept or reject state, which doesn't transition into anything on the TM. So first we're going to consider that case. If Q is the accepting or rejecting state, that means that some point in the middle of the string, we accepted or rejected. So we're just going to carry that information all the way to the end of the string so that we can make the right decision. Otherwise, this is the more interesting case, where Q is not a pointless state. Observation 1 says that M will either halt without moving or it will eventually move right. So if it halts without moving, it's going to be in a well-defined accept or reject state, again based only on Q and A. So we're just going to set the transition function accordingly. If M accepts without moving right, we set it to Q accept, and otherwise we reject. And otherwise, if we don't halt in that position and we eventually move right, we're going to end up in some state Q prime, and that's just what we're going to set the transition function to. Now our initial state is going to be the exact same as the initial state in the TM. Finally, we just have to construct our set of accepting states, F prime. Now, we definitely want the accept state to be an F prime because remember, we could have accepted somewhere in the middle and carried that towards the end. But we're not done yet. Remember, in the TM, when we reach the end of the string, we might do some extra work on the blank portion of the tape before we finally accept or reject. So all we're going to do is include all of the states Q, where if we were to start from the blank portion of the tape, at that state Q, we would eventually accept. That is to say, if we were to run M on the empty string, starting from Q, it would accept. And those are all of our accepting states. And it turns out that's the entire construction of the DFA.